Thanks for joining my session. It's almost quarter day, so hopefully you guys have a very great time in the JCon yesterday and today, and probably Thursday and Friday as well. So let's get started. Again, I'm super happy to be here as just first time Cologne, and then the first time in person JCon. So we're going to talk a little bit about the event-driven autoscaling for serverless Java. I got some chance to jump in another session yesterday and today, and then a lot of people are actually a little bit talk about serverless with a very different perspective and persona. So maybe some of the stuff a little bit duplicated, like a Knative stuff, and then like a serverless and Java thing. But I'm going to try to make it more like a differentiated to do that. And then once again, so Kevin, my colleague actually draw me some of the sticker here. The Quarkus sticker is specifically customized JCon stuff. So after session, feel free to grab some sticker here. All right, my name is Daniel O. I'm working for Red Hat as developer advocate, specialized cloud native runtime, for example, Quarkus, Spring Boot, and JavaScript, like a Node.js and TypeScript. And I've been spending a lot of time bring more Java application and workload into cloud, such as Kubernetes. And I'm based on Boston, United States. It's along the way from Boston to here, like a Monday afternoon. I gotta took the flight in the Monday, actually Sunday night, and then I flew through Amsterdam and arrived in Frankfurt, and I needed to take a train from Frankfurt to Cologne. I actually met Mary, my friend, and then in the station in Frankfurt. And then my train was a rapid train. It should be arrived in like 55 minutes. But my train stuck in somewhere, but I have zero understanding the Germany, and then it's a stop somewhere in the middle between Cologne and Frankfurt, more than 35 minutes. And I literally arrived almost same time with the Mary because her train is pretty much slower than mine, and then I actually bought it the ticket very expensive cost. So yeah, that's very interesting stuff when I arrived here. And yeah, so and I also spent a little bit more time to uh, build some practice rather than just hello world demo and around the serverless and service mesh and then GitOps like a Tecton pipeline and then like a Argo City and then how to mingle and then combine your application with that advanced cloud network technology. I'm also Java champion and then CNCF, aka CNCF, like a Cloud Network Computing Foundation ambassador for the past years. So which allows me give more opportunity to meet a lot of awesome people, so like you guys, and then share my experience and the expertise and thought around building new technology for cloud network application, also Kubernetes network application. Here's my contact information. You can follow my Twitter and then subscribe my YouTube channel and also my GitHub repository. You can just fork and then use whatever you want and in my book as well. So just feel free, reach out to me after session. I'm more than happy to have more connection with you. Okay, I'm pretty sure you already heard about that Kubernetes and then like a serverless and things like that. And then I got one simple question. How many of you actually have some experience to deploy your Java apps into Amazon Lambda? Wow, no one. That's fantastic. I really like that. So this is literally like some auto scaling architecture on Kubernetes. So Kubernetes actually provide the out-of-box feature, Horizontal Pod Autoscaler, aka HPA, which allows you set up auto-scaling configuration for each container pod. And once you set it up, and then it automatically scale out and in based on resource utilization, such as a CPU or memory. And then this is really fantastic when Kubernetes came out. It's almost 2014, like almost 9 years ago. That is one of the beauty of the Kubernetes feature. However, things change a lot because a lot of company, a lot of application already move forward to Kubernetes with the containers and then auto scaling, self-healing, replication, things like that. And then, okay, so I just give some experimental thing, run my Java, .NET, Python application on Kubernetes. And now, what is the next step? Okay, I have more like a backend services based on my whole application portfolios. And then I need to bring more application backend server, database, or messaging server running on Kubernetes. But also, you really have some big concerns. Is it really safe if I just bring existing like a backend services into Kubernetes? Maybe it's not ready. So that's why you still need to connect to backend services, like AKA external services for your application workload. So here's a good example. So you could maybe connect to external services like a Kafka cluster or Prometheus or Azure Monitor or Amazon CloudFormation. It's all about external services trigger your events streaming. So based on your event streaming or event-driven architecture, you first need to redesign your application itself, like a reactive programming. It's regardless of Java, like any kind of program language, you need to redesign more reactive programming. And then you can also redesign your architecture, like a networking or a processing and the dispatching. There are many kind of persona you have to redesign. And then, some of the application, for example, here is a very simple retail application. So I have one application, for example, inventory, which needed to be scaled out based on the AWS CloudFormation messaging. And then the other application, like an order, that should be scaled out and in based on Kafka messaging. And the other one, like a cart, is maybe scaled out in based on a metric from Prometheus. You can be sure I can have only one external service to driven and trigger my event-driven application. So how do I do that? So with the Kubernetes, Kubernetes also provide the custom resources definition. So you can actually define custom resources along with your own purpose. So with that, Kubernetes let us create custom metrics. Is some kind of adapter between your application and external services. For example, the AWS CloudWatch metric adapter and the Prometheus metric adapter, and then Azure Monitor metric adapter. But here's the one big challenge just come to us. That is we can only enable one metric adapter in the single namespace. So one single namespace, you don't want to deploy one single application on the single namespace. Then it's a namespace of literally some kind of your business domain or project. And then that project includes multiple microservices, not only Java, but also like a JavaScript, like a Node.js for front end, and one of the backend services like a Spring Boot and Quarkus, even Tomcat or Python. So there are many different applications combined into and deployed in one single namespace as a part of your definition of a business domain. And then, but each application container pod should be scaled out and in and triggering by different metric services. But with this custom metric adapter based on Kubernetes, you cannot do that. So that's the big problem. That's really KEDA actually came out to overcome this problem. So KEDA is a really acronym, Kubernetes Event-Driven Autoscaling. So here is the bottom line. You don't need to change anything on existing resources, for example, deployment or batch job. You just keep using existing resources on Kubernetes, but also you just create a new resources on manifest and KEDA, aka scaled object or scaled batch job. And that literally point to your application and decide the time when you need it to be scaled in and out. So Red Hat and then Microsoft, we spend a lot of time and effort to create this open source project, and we donated CNCF, and then this literally turned into incubation project 2 years ago. And now recently, we released a couple of months ago to 10. And then actually last week was supposed to be released to 11, but we got a small issue, so we still take some time to verify all functionality in the last snapshot. So you can go to keda.sh, the URL. You can find more detail. And then there are more than like a 61 scalars, which allows you connect to like a Prometheus and a Kafka cluster, and then like a RabbitMQ, and then a lot of things you can use that for your event-driven application and networking connection. You can install KEDA using operator, or like a Helm chart is more preference by developer. So with the KEDA, just so you can see that architecture a little bit changed it. First of all, you cannot find HPA anymore for each application part and the bottom line. As you can see, there is no HPA is gone. And then HPAs are replaced with scaled object. However, KEDA actually only manages scale 0 to 1, 1 to 0. But that's not enough, because you have maybe million events streaming for the next 2 minutes from like a Kafka cluster. And the one container pod, doesn't matter how big it is that you cannot process one container pod for million event streaming data for the next 1 minute or 2 minutes. That's why we need to more scalability, not just one, like maybe 10,000, 1 million. So that's the KEDA actually invoke existing HPA, and HPA allows you to scale from 1 to XYZ, whatever you want. So it's literally KEDA only manages 0 to 1, 1 to 0 based on your incoming network traffic, but also eventually scale out to more than 1 based on HPA integration. Now you can enable with this KEDA architecture more flexibly, dynamically, with a single namespace, with a multiple external services based on your application characteristics, which is really awesome. And then this is just some architecture concept, like a 10,000 feet, what kind of module and components you really want to use based on KEDA. And the scaled object and scaled job is allows you to define your specification. Where is my target application source? And then what is the triggering? So this is you're gonna just set it up. And then here is some example, like literally YAML file. I know, so YAML file is not same as JSON, which developer don't like that. Me neither. But you still need to create YAML file as long as you want to use Kubernetes on your daily job, or sometimes once a week. So this is a really scale job, and then I'm gonna show you real soon with some nice live demo thing. And the one thing is under the spec on the right hand, there are scale target references, and the name equal is literally your target resources. For example, your deployment name. And then in the trigger section, you can see that what is your trigger scale in and out. So for example, here is Kafka cluster. So which means the KEDA keep monitoring the Kafka cluster, which means it keeps scraping all metric data from Kafka cluster, and then now decide, okay, this is the right time to scale in and out for targeting application, which is this example dash deployment. So and then what about this serverless autoscaling? So some people ask me, hey Dan, I think KEDA is a sort of a serverless, because you just mentioned the KEDA manages application scalability from 1 to 0 and 0 to 1. The 0 means it's just literally like a serverless, like Amazon Lambda or Azure function, Google function. But this is not fully pure serverless, because when you deploy application to serverless in a Lambda or Knative or whatever you need, and then once deployed, and then if there is no incoming network traffic, the application automatically scales down to 0, like a hibernate, idle, nothing in there. That's really serverless behavior. However, KEDA, when you deploy, you can deploy like a normal application, which should be running on all the time, 24/7. Even if there's no traffic, it's not going to scale the down 0 by default. And when you set it up KEDA, and then you just started is processing incoming traffic, and then KEDA try to scale up and down, and then it eventually scale down to 1 again. There is no traffic anymore, and then finally it scale down from 1 to 0. And then after that, you got really similar behavior like Amazon Lambda. But at the very beginning, it's not the same thing. So that's, we're not going to say KEDA is 100% serverless. So, and then Kubernetes ecosystem also have a serverless tool and project, which is Knative. It's a routing developer to manage your application, containerized application, deploy, and then have a same serverless behavior, just like Amazon Lambda. The idea to develop Knative project, because the many enterprise companies already made decision. Okay, we're gonna go to Kubernetes, and then we're gonna move application to Kubernetes as many as possible. But sometimes, and then they hire some like a analyst team, and then try to monitor and observe some metrics data or workloads, and then bunch of those utilization metrics for the past 6 months. And now they realized that, okay, so we realized only less than 20% application should be running all the time, just like a 24/7. However, the other 80% application, yeah, it's just very low CPU or memory utilization, less than maybe 10% of our resource capacity. The reason why the end user could be human being, or could be your IoT devices, or some of the other RESTful API. It's not called all the time. It depends on some kind of activity or events. So with that, how to save our infrastructure costs? Serverless is a good solution. However, still there are challenges, as you probably know, the cold start strategy. It's going down, it's a 0. And then you got some network traffic, it's going up. But it takes some time, depends on your serverless platform, as well as how big your application is as well. So sometimes, yeah, so maybe a couple seconds is good enough, but it depends on end user. So for example, I have 2 kids, one 10 years boy and 6 years girl. So my daughter, whenever she watches some kind of YouTube or like some kind of video stuff, TikTok, and then it's nothing show up in the 2 seconds, she just leaves. And then she said, oh, something wrong in there. So it's all like a personality and a preference. And a lot of people actually, more younger generation, they already get used to have some really good experience, like a 5G internet rather than 3G and modem. You know that? So they have a really good patience. So maybe 2 seconds, 3 seconds is not fast enough. So that's really cool to start in Amazon or Google. However, if you have a big microservice application with the containerization or not, maybe it takes more, like maybe 10 seconds or even 7 seconds. It's a way slower than you expected. So that's why a lot of people, a lot of enterprise companies really hesitate to go to Amazon Lambda still. So there are many effort is happening, not only platform, but also application layer. And then another big challenge for that, okay, so yeah, we're gonna just made a decision, go to the serverless, not whole application, maybe less than 5% application, not business critical, but it's more like a web application. However, but we already have Kubernetes, doesn't matter Red Hat OpenShift or EKS or AKS, just Kubernetes. But we don't want to have a multiple platform, like a siloed architecture, because this business application, same thing. Why we need to go into Amazon Lambda rather than just try to use existing Kubernetes cluster? That's the goal of the Knative project. Just keep using Kubernetes, not only like a normal application, but also serverless application functions. So here's a very interesting blue points you might want to ask, because whenever I talk a little bit about serverless and then specifically KEDA and Knative, it's a little bit similar pronunciation. Sometimes I compute literally. And then it's okay. Knative is a serverless on Kubernetes. KEDA is a little bit like a sort of a serverless on Kubernetes. And then which one do I need to use for my application? And then which one would be better? And everybody say, yeah, so it depends on your expectation or circumstances. But here are just some kind of bullet points. And Knative is a totally different project, which means you cannot use existing running resources. You already deploy application, you need to rewrite your Kubernetes resources YAML file based on Knative specification, like a Knative serving, like a Knative services, and Knative eventing as well, and then redeploy that. So that is the first challenge, not only developer, but also the platform engineers. And another thing is, you also need to rewrite your existing application, Java, .NET, Python, etc. Because Knative recommend you need to use Knative eventing infrastructure, how to sync your event-driven messaging, or how to send in, consume your application, and then your event-driven infrastructure, such as Kafka or AWS messaging server, or just AMQ messaging broker, or RabbitMQ, or Redis streams. So it's not going to allow you directly connect to that event infrastructure. This is a really Knative architecture and components. And by the way, KEDA, I already mentioned earlier, you don't need to change anything on existing Kubernetes resources. You just point to and create a scale object, and then just make that happen. So that's really big change that, and KEDA still using HPA, Horizontal Pod Autoscaler. However, Knative, they has own autoscaler, like a Knative autoscaler. So it's totally different anymore. But one of the good benefit of Knative is you really have a fully functional serverless capability, just like Amazon Lambda on top of the Kubernetes. So I'm gonna showcase 3 different demos, which is really we're gonna evolve existing autoscaling architecture based on Kubernetes with a bunch of the other technology, and then just like, is that the best one? No, we're gonna more and improve that kind of stuff. So first demo is not event-driven application. The reason I want to showcase this first demo, so you can figure out what is a potential problem just using HPA, just like I showed that in the slide deck, but at the very beginning. So I'm gonna use Quarkus as Java application. The reason why this whole architecture actually not 100% related to Quarkus. You can use any Java application. But the reason why I'm using Quarkus, I'm going to talk the reason during the demo. And then let's get into the demo. All right. Okay. Oh, weird. Give me a second. So this is my demo environment. It's an OpenShift cluster, and you can actually use a developer sandbox. When you go to developers at redhat.com, and then go to start building, and then start building, and then here's the developer sandbox for Red Hat OpenShift. It's built on laced Kubernetes, and then you can just sign in for free, like your email or your phone number verification, and then Red Hat give you free Kubernetes cluster for next 30 days. And after 30 days, we will email you. Your user ID will be deactivated because you fulfill 30 days. And then when you try to re-log in, and then your ID automatically reactivated. And then you're going to have another 30 days to use a free Kubernetes cluster. So yeah, feel free try to use that. I'm going to try to do a similar thing. And I already installed a bunch of the operator to serverless based on Knative, and then KEDA as operator, and then Kafka also operator. So this is the first project, like a Kafka-HPA namespace, and then this is my Kafka based on Stream is just not only Kafka, but also Kafka and Zookeeper to have some clustering stuff deployed by operator on top of the Kubernetes. And this is my Quarkus application. And then when you click on Quarkus application, just take a look at the logs. And then it's already connect to my Kafka topic. The name is my dash topic. And then I'm going to use a race Quarkus version 3.1.2. And then it start 5 seconds to set up all kind of thing. And then back to the application. And then I already set up autoscaling configuration, HPA. That's why you can see that autoscale set up. And then there are HPA already created that. And then here is the target. It's a 70%, which means when I try to create some bunch of the event streaming data, like event streaming data, based on Kafka topic, like for example, dummy data every single second until 5 million record. And then the Quarkus application consume that the events data from the Kafka topic. And then once the container pod, the CPU utilization reach out to 70%, and HPA, okay, now time to scale up. This is 70%. Okay, I'm not gonna set up the 90%. It's not real. And no one actually tried to set up 90% in the production. Okay, and here's my project. So this is the first project. The first reason I use the Quarkus, because the Quarkus provided OpenShift extension. It's something like Maven dependency. When you go to POM.xml, now you can see that here is the Quarkus-OpenShift extension, which allows me skip a lot of the inner loop process or some of the outer loop process as well. So as the known practice is for developers, when you develop application and then now you're going to deploy this application to Kubernetes, what kind of required jobs you need to do? First, you're going to create a Docker file and then containerize your application for like a local environment, like a Docker images. And then you're going to tag the Docker image based on your external container registry, such as Docker Hub, KEDA.io, or Google Container Registry. And then after that, you can just push that image into that your desired container registry, like using Docker push or Podman push. Just first step. And then you're going to create Kubernetes YAML file for deployment and also create a bunch of others like services. And then if you use my ingress routers, you can also use the ingress router YAML file, things like that. And then you're gonna run that YAML file using kubectl, like kubectl and -app apply, and then that YAML file. Make sure log in your cluster from your local, and then just apply for that. Without error, the Kubernetes worker automatically found out best available worker and pulled out container image from that container registry and running on it. So this is really the developer new responsibility. You can also have the fantastic CI/CD pipeline. It's automatically build, deploy, integration test, things like that. However, this is more like for your production or staging server, rather than your just personal verification or testing on Kubernetes. So Quarkus actually allows you to generate a bunch of the Docker file when you go to, excuse me, when you go to Quarkus project, and you can have some Docker file under the source directory and the main. You can have automatically generate Docker file for JVM. Let me go revisit this kind of stuff. First of all, I'm going to go to like a Java method here. So this, and then here is the one of the other reason is why I'm using the Quarkus, because I need to rewrite my application more reactive way. So if you are like a Spring developer and then you have some experience to change or rewrite or migrate your existing Spring Boot to Spring Reactive, it's totally change animal, a lot of stuff. So you need to use Spring integration ecosystem, or you can add the Spring Cloud ecosystem, and you can also implement Spring function on the method level. For example, you need to connect to Kafka cluster or messaging broker, things like that. And also, Return signature is totally different. You can also wrapping like a mono webhooks based on monoflux based on Spring webhooks. So you need to migrate all single by single, line by line, all your application. So Quarkus is pretty much easier. Let developer implement reactive programming because Quarkus actually was born based on reactive engine such as Netty and ProX. However, Quarkus also allows developer keep developing non-reactive application. So you can do that both, whatever you need. And then, for example, the Kafka cluster, I already created the Kafka cluster and then create the topic and name on my dash topic. And then I just need to only one annotation here on method level. So incoming, which allows my method, receive method, just to consume the message from Kafka topic. If I set it outgoing and the topic name, I'm gonna sending out my JSON format like a data into that Kafka topic. And I'm gonna set the channel, it's between like a application and a Kafka and messaging broker stuff. It's pretty much easier. So what other like a Kafka configuration here? So in the Spring Boot, you need to like Kafka composer, like some like a constructor. You need to create that, or you can just set up Docker compose, things like that. And the Quarkus actually provide property, and then you can actually set it up where the incoming property and set my Kafka Bootstrap server, and then you can also locally testing Kafka cluster based on test containers. But you don't need to add the test container configuration on your POM.xml or Gradle file, and you don't need to set up all default like where is my Bootstrap server or where is my like some bunch of the configuration around the Kafka cluster. You don't need to do that because Quarkus automatically bind that by default keeps and value configuration automatically. You can also override the Bootstrap server name or username, password, or things like that. So that's another reason why I use Quarkus. And here is Kubernetes OpenShift configuration. So I'm going to deploy my application to Kubernetes, and then you can change the target Kubernetes or OpenShift and also Knative for serverless application. And then I'm going to set min-max this kind of stuff. I already deployed the Quarkus application, and let me try to run some like a performance script here. So luckily, the Kafka cluster already have some performance processor bash script, aka Kafka processor performance test bash script inside the Kafka cluster. When you deploy Kafka cluster to Kubernetes using StreamG project. And then I'm going to use the same name, my topic, and then throughput is 1 million. And then I'm going to create that dummy record, and every single second, this is 1,000 milliseconds, which is 1 second. And I'm going to do the parallel like a 5 container pod. So back to my console, you can actually run using like a OC command line or kubectl, or one of the beauty of the OpenShift cluster provide the beauty web console. And then I just create that, and then you can see that 5 pod is already created batch job, and then go to the view logs. It's literally, you can see that already like maybe 15 more than 15 like 150,000 record already sent to Kafka topic. And then when you go back to my Quarkus application, it's gonna be crazy busy. As you can see, the line is already keep increasing, like almost 2,000 and 3,000, and then like 4,000, and it's gonna be soon it's 10,000, something like that. So and then it's really super busy in my one Quarkus application, and then job is already done, which means the job is already sent out 5 million record to the Kafka topic. And then my Quarkus app needed to process 5 million event streaming for the next couple of minutes. And then as you can see, it's HPA will literally scale out too in the meantime. When you go to HPA, you can see that it's literally scale out because the CPU realization is also 95%. Okay, it's already scale out 1. but it's pretty slow. When I go back to here, and I still, and then the other container part is the reload balancing, and then but still a lot of work to do. So I feel it's 2 container part is not enough to process 5 million data, just like a event-driven and reactive programming expecting high concurrency, but this is not high concurrency. So let me go back to slide, and then moving forward to second demo. So second demo, we're gonna give us some chance to redesign using KEDA. As you can see, so KEDA actually keeps scraping your metric data from Kafka, and then in the meantime, your application keep processing your messaging with the Kafka cluster, and then in some point in the future, the KEDA actually let your application scale out based on that scrapping data. So let's go back to the application, and then I also create this YAML file, which is the same Quarkus version here 3.12, and then I set an environment variable. Here's a Kafka bootstrap, which is the same thing. So let me switch it to new project, Kafka KEDA, and then there's no Java application, only Kafka cluster. And then I'm gonna create a new deployment here. And also, like I said, I'm gonna create this scale object. Scale object, we're gonna point to target is Quarkus EDA demo, which is literally same name of this application, Quarkus EDA-demo. And then what is the trigger? It's the Kafka cluster based on the service domain name, and then Kafka topic. So before I create the scale object, I can actually scale up and down manually, which is not set up auto scaling. So because I didn't set it HPA, but like I said, when I create the scale object, it automatically set it to auto scaling because HPA automatically create based on scale object. So this is one of the really good impressive thing by KEDA. And then when you take a look at my application, just make sure the same version 3.12, and then my topic. I don't want to cheat the performance test here. So go back to my application, and then I'm going to use the same performance tool, and then create the 5 batch jobs. We created like a 5 million dummy record. We'll send it to Kafka topic, and then my Quarkus application literally consume that application. So create a 5, and then it's literally, you can see that it's already scaled out to 4. So this is one of the beauty of the KEDA. Even if not 100% fully support serverless, but it's already scaled out 4, and then now it's scaled out 8, and then it's scaled out to 10 because I set up the maximum, which is like a 10 on my application side. So this is literally how to use the serverless, like a not 100% serverless, but KEDA is way better than just using HPA, specifically event-driven application. And now I'm going back to the slideshow again. And then, so what about this serverless just using Knative? Because some people are asking me, like I said, okay, which one do I use that? So we are more than 100% serverless, just like Amazon Lambda experience on Kubernetes. So you're going to go to Knative. So how to redesign my event-driven auto-scaling architecture with the Knative? As you can see, Knative a little bit different. First of all, here is the Knative eventing infrastructure, like how to communicate and as a liaison between the application and Kafka, which is the Kafka source, or they are ping source, or like many types of a source. In this event, infrastructure actually consume your messaging from Kafka rather than directly from your application, and then this messaging passed down to your application as long as you deploy application as Knative services. And then Knative actually directly monitor your application and then scale up and down using Knative autoscaler, not HPA. And then when you go back to project, and then I just forgot one thing. When you go to target directory, I already deployed my application with the Kafka HPA project. So that's why when you go to target directory, Kubernetes directory automatically generated based on Quarkus OpenShift extension. It creates the YAML file automatically, like the service definition, and then like image metadata, which is image stream, and the build configuration, and also deployment configuration. So you don't need to write, or you don't even need to copy from existing Kubernetes YAML into your application. It's generally automatically generated for this YAML based on your application side. So that's the third reason why I'm using Quarkus today. And then, so I'm gonna change my project because I needed to go to project, and new project is Kafka Knative, and then there's only Kafka cluster. And let me change the project Kafka Knative. Now I'm here, and the same project, which is a Knative demo. So Knative demo is literally I need to rewrite my application itself, but luckily my application doesn't have any business logic, just print out the logs. But in order to using cloud event message rather than like just JSON, you need to rewrite your method like a Java or .NET, whatever you need. So because you got a big challenge to build up event-driven architecture on top of the Kubernetes or multiple cloud, so sometimes your application just prefer to use a JSON format, or sometimes your application just product buff or binary. How to transform across different formats? Cloud events actually solve the problem to provide the standard events messaging format. So Knative eventing actually adopted and referring to cloud event project, which is one of like a CNCF project as well. So in order to use cloud eventing stuff, you also rewrite and modify existing method in the Java application. So I'm gonna deploy my application to, and then one more thing, when I go to resources, and then you cannot find anymore the Kafka stuff. Previously, when I go to resources, you can have all Kafka resources here, but this is all configuration moving to Kafka Knative event infrastructure. It's just get rid of from your application side and move it to your resource infrastructure. And then one interesting thing is here's a target is Knative, which it was in OpenShift in the previous project. So let me go to here and then try to build application. The Quarkus CLI is one of the good things. You probably saw that in the previous session, and some Kevin or the other guys actually use that. You can actually literally use a Maven command line or Gradle as well. But one of the good things is Quarkus allows to make it easier to build, deploy, and then like a push container image and add extension. You don't need to memorize all parameters and arguments when you use Maven or Gradle. So I'm just compile this application like a fast jar. We're not gonna call that Uber and fat jar because Quarkus literally override class loader, and then it allows make it a little bit faster the jar file. That's why we fast jar, and then containerize the application based on Docker container, Docker file, and then push it into container registry inside the existing OpenShift cluster. And I'm going to go back to here. Now I got a serverless application is now on. And then I'm going to create a Kafka source as a part of the eventing. So here's my Kafka source. Now you can see that Bootstrap server configuration here rather than application side. So I'm going to create that thing. And then, so my application will be scaled down to 0 in in 30 seconds. The default configuration is the same version. The default configurations Knative scaled down to 0 is 30 seconds. So in the meantime, let me try to deploy one last thing. We are running out of time. So the last thing is this is really the main goal of this topic. So is there any other better way to use Knative benefit as well as KEDA benefit for serverless and event-driven So sure, that's really I want to talk about today. So we have a sandbox project which integrates between KEDA and Knative. You don't need to pick one of them anymore. And then this is KEDA actually autoscale Knative eventing infrastructure. For example, in this demo, Kafka source, as well as the application itself. So you can see that when you scale out the Knative project, so Knative project already scaled out to 1. The maximum is just 1 pod, not 10, not 1,000. Only 1 is not enough, even if it's a serverless behavior. But this KEDA Knative allows you this architecture. So KEDA is scraping metric data from Kafka. It's really same thing in the KEDA, but it's the scaled out Kafka source right now. It's a multiple process parallelly, as well as Knative also scaled out Knative services as a Quarkus application at the same time. So it's a way faster and flexible to scale out your application. So back to the application, my application scaled down to 0. And then let me try to batch job once again, and then create 1. And then when you scale job, and then my Quarkus application literally scaled up soon enough. And then, but it will not scale out to more than 1 pod. So now the application, now you can see that it's a scale 1, and then when you choose the network traffic, it's already a super overflow. It's swarm into millions data, but it's not going to scale up. I'm going to try to change my last project, and then let me go to a little bit change my application side. So this is image group compilation, which is a really namespace. And one of the beauty of this sandbox project with the Quarkus, you can actually set up Knative compilation here. And also I have, first of all, I'm going to deploy once again. I'm going to change the project. Kafka, KEDA, and Knative. And then once again, build testing. And then back to the application. Here's a new Kafka source manifester. And then as you can see, we have annotation. This is actually implementation on this sandbox project. It allows you to set up KEDA, Knative compilation at the same time. So we combine KEDA, Knative at the same time to make it better, high concurrency for event-driven Java application. But this is not really only focused on Java apps, but also you can use any other language platforms such as Python, .NET, or whatever you need, as long as you use Knative, KEDA integration, as well as like a backend services, Kafka or AMQ, AWS SQS services, things like that. Okay, I'm gonna copy this one, and then once you create that, I'm gonna add on. So let me try to go back to first project, and then the job is done, and then application scale down to 1, just back to the normal. And then the second KEDA is the job is done, and the application down to 0, no more pod. Now you can say, oh, it looks like a serverless. And then Knative project is already jobs done, but the application still 1 pod. And then it will eventually scale down to 0, but it takes a long time because it's just 1 pod. And then last project, Kafka Knative here. Now I have an application, and then I'm going to create a new Kafka source. It automatically attaches it to my application. And one last piece, I'm going to run this kind of thing. But I'm going to give it a few more seconds to scale down to 0. In the meantime, let me go back to slide deck. I'm sorry about that, really running out of time. So one last thing is, so it's we have a more autoscaler integration as a backend service. So not only Kafka source, but also AWS SQS source, and the Redis stream, and the RabbitMQ. We're gonna try to integrate more and more like a event-driven source. And then one of our goal is we're gonna scale out directly Knative service rather than Knative eventing infrastructure, which means we're gonna get rid of the middle layer, which allows way faster and dynamic auto scaling for event-driven application. Okay, I already created a bunch of the tutorial video, include this demo and session, you can visit my YouTube, like Daniel TV, in the URL. It's more than happy to subscribe, and then just check the video. And if you wanted to replicate this kind of stuff on your local machine. Okay, let's go back to demo environment. Okay, it's scaled down to 0. And then I'm going to try to create a batch jobs. And it just 5, and then going to be sent to 5 million records to Apache Kafka. And now you really see that it's a really fast scale out to 4. But it's so previous KEDA scale out to 4 and 8 and 10 literally. But it's more dynamically keep managing and controlling and monitoring the incoming traffic, and then rebalancing as well as the processing. So if you give some more time, you can see that the scalability, like in and out, very flexibly, like 4 to 8 and then back to the 7, and then that should go to the 10. It's a way more like a flexible rather than just using Knative or KEDA, or even better HPA. That's it. And then one last session slide. We released Quarkus 3. We improve a bunch of stuff like productivity, and then Kubernetes integration, and then we support Java 11 and 17. And then of course the Jacquard 10. You cannot find the Java X anymore in the namespace. And then Hibernate ORN 6.2, and then microprofile 6 as well. That's it. Thanks for coming today, and hopefully you enjoy this demo and session. And feel free to reach out to me if you have any question in person, and then like a social media stuff. And then hopefully you enjoy less of a conference. Thank you.